Preparing for a data science at Amazon interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design an experiment to measure whether a new Amazon recommendation feature improves customer engagement? I would begin with a clear hypothesis. Personalized recommendations increase meaningful engagement without harming customer trust or conversion quality. Randomly assign eligible customers to treatment and control, stratifying by device, region, and customer tenure. The primary metric might be qualified product clicks, with conversion, revenue, latency, and unsubscribe rate as guardrails. I would calculate power before launch, monitor exposure compliance, run the test long enough to capture repeat behavior, then evaluate lift, confidence intervals, and heterogeneous effects. While answering, focus on hypothesis formation, randomization, treatment and control groups, primary and guardrail metrics, sample size calculations, statistical power, interference, and practical interpretation of business impact. Question 2. Which metrics would you use to evaluate the health of an Amazon marketplace, and how would you handle conflicting signals? I would use a balanced metric tree rather than optimize one number. Customer outcomes include purchase conversion, repeat rate, delivery promise accuracy, defect rate, and satisfaction. Seller health includes active sellers, sales concentration, and fulfillment performance. Marketplace outcomes include selection, revenue, contribution margin, and in-stock rate. If conversion rises while returns or complaints worsen, I would treat that as a failed result. I would segment by category and customer cohort before recommending action. Make sure to cover customer, seller, and operational perspectives, selection of North Star and guardrail metrics, leading versus lagging indicators, metric definitions, segmentation, and trade-offs between growth, trust, price, and fulfillment quality. Question 3. Write a SQL approach to identify customers who viewed products but did not purchase within 7 days. I would first deduplicate view and purchase events, then select distinct customer product pairs viewed during the analysis window. A left join to purchases on both customer and product, with purchase timestamps between the view time and 7 days afterward, identifies non-buyers when the purchase key is null. I would partition events by date, filter early, and test boundary conditions such as exactly 7 days. Finally, I would reconcile counts against dashboards and sample records manually. In your answer, discuss event table assumptions, customer and product keys, timestamp boundaries, deduplication, joins, null handling, date arithmetic, performance through partitioning, and how you would validate the resulting population. Question 4. How would you build a fraud detection model for Amazon transactions when fraudulent cases are extremely rare? I would frame fraud detection as a cost-sensitive ranking problem, because missing fraud and blocking legitimate customers have different costs. I would preserve realistic prevalence in validation, use precision recall curves rather than accuracy, and select thresholds based on investigation capacity and expected loss. Features could include velocity, account age, payment relationships, device patterns, and shipping inconsistencies. I would use temporal splits, monitor drift and false positives, and create feedback loops from confirmed investigations. Be sure to mention class imbalance, precision recall evaluation, cost-sensitive learning, sampling strategy, temporal validation, feature leakage, threshold selection, manual review capacity, and monitoring for adversarial adaptation. Question 5. What kinds of data leakage might occur when predicting whether an Amazon order will be returned? Leakage occurs when a feature contains information unavailable at prediction time or directly reflects the outcome. For returns, examples include refund status, return label creation, post-delivery customer messages, or a product rating written after purchase. I would define the scoring timestamp first, build an availability matrix, and enforce point-in-time joins. Time-based validation would expose temporal leakage better than random splits. I would also review feature importance for suspicious proxies and document every feature's operational meaning. Focus on defining prediction time, separating features available before fulfillment from post-outcome signals, recognizing target proxies, using time-based validation, checking pipelines, and documenting feature availability with business partners. Question 6. How would you evaluate and improve a product recommendation system for Amazon customers? I would separate candidate generation from ranking. Candidates could come from co-purchase graphs, browsing history, semantic similarity, and popular items, while a ranking model uses context, recency, price, and availability. Offline evaluation might include recall, NDCG, and calibration, but online tests must measure qualified engagement, conversion, repeat purchases, and customer satisfaction. For cold start users, I would blend popularity with contextual signals. I would also enforce availability, diversity, and trust constraints rather than maximize clicks alone. In your answer, cover candidate generation, ranking, collaborative and content-based signals, offline metrics, online experimentation, cold start handling, diversity, novelty, business constraints, and the risk of optimizing clicks instead of customer value. Question 7. How would you forecast demand for a product sold across Amazon fulfillment centers? I would forecast at the product location level while reconciling forecasts across fulfillment center and network hierarchies. Inputs would include historical sales, price, promotions, holidays, trends, lead times, and stockout indicators. Observed sales must not be treated as true demand during shortages. I would compare seasonal baselines, gradient boosting, and probabilistic models using rolling backtests. Prediction intervals matter because inventory decisions depend on uncertainty. I would monitor bias, service levels, and forecast value added. Make sure to discuss hierarchical time series, seasonality, promotions, stockouts, intermittent demand, regional patterns, forecast horizons, uncertainty intervals, backtesting, and how forecasts influence inventory and fulfillment decisions. Question 8. How would you determine whether faster delivery causes customers to purchase more frequently? Faster delivery is not randomly assigned, so customers receiving it may already be more valuable. My preferred approach is a randomized rollout where eligible regions or orders receive different delivery promises, provided operations can support it. I would measure repeat purchase rate and customer lifetime value over a defined horizon, with cost and cancellation guardrails. If randomization is impossible, I would consider matching, regression discontinuity, or difference in differences, while testing parallel trends and sensitivity to unobserved confounding. While answering, distinguish correlation from causation, define treatment exposure, consider randomized rollout or quasi-experimental methods, control for selection bias, choose retention metrics, examine heterogeneous effects, and account for operational costs. Question 9. Describe a time you used data to make a decision with ambiguous requirements, as expected under Amazon's leadership principles. In an ambiguous retention problem, I first translated the broad concern into a measurable question. Which early behaviors predict a second purchase? I combined event data, customer interviews, and cohort analysis, then proposed a low-cost onboarding experiment. I aligned stakeholders on one primary outcome and explicit guardrails, documented assumptions, and launched despite incomplete information. The experiment improved repeat purchase rate while reducing irrelevant messages. I communicated the result honestly, including limitations, and converted the analysis into a repeatable mechanism. Be sure to explain the ambiguous customer problem, assumptions, data collection, alternatives considered, decision mechanism, measurable outcome, stakeholder alignment, and how you demonstrated ownership and customer obsession. Question 10. Design an end-to-end machine learning pipeline for predicting late Amazon deliveries. I would ingest order, carrier, inventory, route, weather, and facility events into version storage, then generate point-in-time features to prevent leakage. A scheduled training workflow would use temporal validation and publish a registered model with approval checks. Real-time or near real-time scoring would feed promised date decisions and proactive notifications. Monitoring would track latency, calibration, drift, subgroup performance, and business outcomes. I would retain a rules-based fallback, audit predictions, and retrain when performance or data quality crosses thresholds. Cover data ingestion, point-in-time feature generation, training and validation, deployment, latency, batch versus real-time scoring, monitoring, retraining, explainability, failure handling, and integration with customer communication or operations. Question 11. How would you handle missing values in customer and order data? I would not automatically replace every missing value with a mean. First, I would profile missingness by source, time, customer segment, and outcome, asking whether absence itself carries meaning. For numeric variables, median or model-based imputation may work. Categorical fields can use an explicit unknown category. I would add indicators when missingness is informative and fit imputers only on training data. For MNAR patterns, I would test sensitivity, investigate upstream fixes, and measure subgroup impact. Discuss why values are missing, MCAR, MAR, and MNAR assumptions, meaningful missingness indicators, imputation choices, train test separation, categorical handling, bias risks, and validation against operational data quality rules. Question 12. How would you choose between logistic regression, gradient boosting, and a neural network for a customer prediction problem? I would establish a simple baseline first, usually regularized logistic regression, because it is fast, interpretable, and often well calibrated. Gradient boosting is my next choice for structured Amazon-style data with nonlinear interactions and missing values. Neural networks become attractive with very large datasets, sequential behavior, text, or multimodal inputs. I would compare models using business-relevant metrics, calibration, latency, and operational cost. The most accurate model is not automatically best if it cannot be trusted or maintained. In your answer, compare data size, feature types, nonlinear relationships, interpretability, calibration, latency, maintenance, distributed training, baseline performance, and the business cost of model complexity. Question 13. How would you explain a model that declines a seller's or customer's request? I would provide a local explanation showing the main factors behind that specific decision, such as missing documentation, unusual activity, or a delivery risk pattern, while avoiding sensitive implementation details. I would validate explanations with methods such as SHAP and counterfactual tests, but treat them as diagnostic rather than proof of causality. I would audit outcomes across relevant groups, offer an appeal or human review path, and state uncertainty clearly. Explanations should help customers act, not merely justify the model. Focus on global versus local explanations, actionable factors, confidence and uncertainty, fairness checks, counterfactuals, auditability, privacy, human review, and communicating limitations without exposing sensitive system details. Question 14. How would you estimate the causal impact of a promotional discount when randomized experimentation is unavailable? I would first identify variables influencing both discount assignment and purchase, such as customer history, product demand, seller behavior, and seasonality. If suitable pre-period data exists, I might use propensity weighting or matching, then estimate effects with regression adjustment. A difference in differences design could help if some comparable products received discounts and parallel trends are credible. I would test overlap, placebo periods, spillovers, and sensitivity to hidden bias. I would present the result as an estimate with explicit assumptions, not certainty. Make sure to cover treatment definition, confounding, propensity scores, matching or weighting, difference in differences, pre-trend checks, spillovers, sensitivity analysis, heterogeneous effects, and limitations of observational conclusions. Question 15. When would uplift modeling be more useful than a standard response model for Amazon marketing? A standard response model predicts who is likely to purchase, but uplift modeling predicts who purchases because of the message or incentive. That distinction prevents spending discounts on customers who would buy anyway and avoids annoying customers who may react negatively. I would collect randomized treatment and control outcomes, estimate individual or segment-level treatment effects, and evaluate incremental revenue or profit on a holdout population. The model must include incentive cost, channel fatigue, and uncertainty, with conservative deployment for weakly supported segments. Discuss incremental treatment effects, persuadable customers, treatment and control data, targeting costs, randomized training data, uplift evaluation, treatment harm, and why predicting purchase probability alone can waste incentives. Question 16. How would you analyze millions of Amazon customer reviews to identify product quality problems? I would combine sentiment with aspect extraction because an overall rating can hide a recurring battery, sizing, or packaging problem. I would sample and label reviews, detect language and spam, then use a classifier or embeddings to group issues by product, seller, and time. I would validate topics against human judgments and correlate emerging signals with returns, defect reports, and customer contacts. A prioritization score should consider frequency, severity, confidence, and trend acceleration before routing findings to owners. In your answer, cover text preprocessing, aspect-based sentiment, language and spam handling, topic discovery, labeling, aggregation by product and time, severity prioritization, validation, and connecting signals to returns or defects. Question 17. How would you forecast demand when a product has frequent stockouts and only intermittent sales? Observed sales are censored during stockouts, so I would not interpret zeros as weak demand automatically. I would reconstruct availability windows, use replenishment and search signals to estimate lost demand, and model intermittent patterns with methods such as Croston-style baselines or hierarchical approaches. Similar products and categories can provide useful shrinkage for sparse items. I would backtest against periods with adequate availability, report uncertainty, and evaluate forecasts through service level, excess inventory, and lost sales costs. Be sure to distinguish observed sales from latent demand, incorporate availability and lost sales signals, use intermittent demand methods, borrow information across similar products, validate with censored observations, and quantify inventory consequences. Question 18. How would you detect unusual behavior in Amazon fulfillment center operations? I would define anomalies relative to comparable facilities, shifts, product mixes, and seasonal volume rather than use one global threshold. For labeled incidents, I would build a supervised classifier. Otherwise, robust control limits, isolation forests, or change point detection can surface unusual patterns. Alerts should include context, severity, and likely drivers, not just a score. I would tune thresholds around operational capacity, investigate false positives with domain experts, and measure whether alerts reduce defects, delays, or safety incidents. Focus on defining normal behavior, choosing supervised or unsupervised methods, seasonal and shift effects, robust baselines, alert thresholds, false positive costs, root cause investigation, and monitoring whether interventions improve operations. Question 19. How would you communicate an analysis to an Amazon product leader who wants a quick answer but the data is inconclusive? I would start with the decision implication. The current evidence does not support a confident launch, but it identifies a low-risk next step. I would show the estimated effect, confidence interval, sample size, and the most important data limitations in plain language. Then I would present options, including proceeding with guardrails or running a focused experiment, and explain their costs. I would avoid false precision, make my recommendation explicit, and define the evidence needed to revisit it. Make sure to lead with the decision, quantify evidence and uncertainty, separate facts from assumptions, explain limitations, offer practical options, recommend the next test, and connect the analysis to customer and business outcomes. Question 20. How would you decide whether a machine learning model is worth deploying when it improves accuracy but increases operational complexity? I would evaluate the model as a product investment, not merely by accuracy. I would translate metric improvement into incremental revenue, reduced defects, faster delivery, or better customer experience, then subtract infrastructure, labeling, monitoring, and maintenance costs. I would compare latency, reliability, calibration, and fairness with the existing baseline. A shadow deployment or limited pilot could validate real-world value without immediate risk. If gains are marginal, I would choose the simpler system. Complexity needs a measurable payoff. In your answer, compare incremental business value with infrastructure and maintenance costs, quantify errors and customer impact, assess latency and reliability, consider interpretability, run a shadow or pilot launch, and define rollback criteria. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.